And we want to write this in, again, interval notation. So start with negative infinity. They go in the same order. -5, use a U for union, 4 to 10. Okay. So that is what we've got, and that would be your answer there. And that, again, was question number 6 from 1.7. Next, we'll look at question 7. Question 7 is another thinking question. Whenever you have squares like this, we need to think about the result. Right? And we need to think about what we're going to get when we square numbers. So just like we did earlier when we looked at question 4, when you square a negative, what does it become? It becomes positive, right? It can never be negative because when you square a number, it must be positive. Okay, so let's think about this from an abstract standpoint. What about this x squared out in front? What happens when we square a number? It's either positive or what? 0. What happens with this over here when we square this quantity? It's either positive or what? 0. Now, when we put these together, can we ever get a negative number out of here at all? No. Why not? This is positive or 0. This is positive or 0. When we multiply these together, what does that make it? Positive or what? 0. Okay. Does everyone see why? Because think about it in your mind. Think about squaring numbers. When you square a negative, it comes out to be positive. This is like the absolute values that we talked about, and we're going to talk more about those today. When we have an absolute value of a negative number, what happens to that number? It becomes what? Positive, right? It can never be negative coming out of an absolute value. Same concept here. This is squared, meaning positive or 0. This is also squared, meaning positive or 0. When we put them together, the only thing that we can get out is going to be positive or what? 0, right? Now, positive or 0 numbers, are those going to be smaller than 0? True or false here? Are positive numbers less than 0? True or false? False. So that means then that this one would have what? No solution. Is everyone kind of understanding why? We had to think about it with the squares. When it has an x squared factored out, or when it has a quantity squared in front of it, you have to think about what you can get out. You don't want to have to work this all the way out. You could, because you could take your square root, you could get all your numbers. You'd end up with 3 critical points. You'd end up with 4 from here, -4, because you have the, well, you wouldn't have -4, you'd have, if you work it all out, you'd have a 0 from here, okay, because that would give you one of them, because 0 squared is 0. Then you've got this one here. Well, you'd have to take this and you have to work it out. You'd have to take your square root, move it over, you get a -16 and check. You'd end up with everything being false. Right? And the reason for that is when you square a negative, it becomes positive. This is squared, and this is also squared. So the only thing you would get out is positive numbers, and they can never be less than 0. So there are a few questions like this where you just have to understand the concepts more than doing the mathematics. But you could factor it all out, work it out. You get 0 and you get -16, put them on a number line, check them all. But that's a lot of work. Did we have any others out of 1.7 to look at? Anything else out of 1.7? Okay, we did have a couple of questions out of 1.8. Well, actually just one. 1.8 is absolute values. And so let's look at 1.8. Let's look now at question 3. And we have a minus 8 plus 9x equals the absolute value of 5 minus 10x. Now, whenever we work out an absolute value, we are going to have to work with two equations, a positive equation and a negative equation. So whenever you have an absolute value, regardless of it, if it's an absolute value inequality or absolute value equality, whenever you have an absolute value, two equations. Now, if it's an inequality, you're going to have to graph them. And we're going to be looking at those today. But this one's an equality, so we don't have to graph it, but we have to come up with our two solutions. And those come from the two equations. So the first equation, all we do is drop our absolute value bars. Right? So that's easy. We just drop the bars, and that becomes our first equation. And then we have an or, because that means it's either this answer or the other answer. And for the other one, we just drop our bars on the left-hand side. But for the right-hand side, we put a negative in front. And then we'll just distribute that negative through. So we have a positive set over here and a negative one over here. So let's now finish it out. And this is just simple algebra. We'll do the left-hand equation first, then we'll do the right-hand equation. So I'm going to add the 10x and add the 8. The 8's cancel. We can do it all at once, and you can write it out separate steps if it's easier for you. But we should be able to pretty much combine these together without any problem. The 8's cancel. We have a 9 and a 10x. That makes it a 19x. And then we have a 5 and an 8. Those add together. 5 and 8 makes it 13. 10x's cancel. And we divide by our 19. And now we have x equaling 13 over 19. All right, so is everyone okay with that? Now that is one of them. How do we get the other one? Distribute that negative through. And that's going to then leave you with a minus 8 plus 9x equals a minus 5 plus 10x. Move things around. Watch your signs. It's so easy to make a mistake on something simple like a sign up. So always take your time. Where students make a mistake and where it gets really frustrating is either you lose track of where you're at, which sometimes happens, or you make a very simple sign error mistake. So always take your time. Try to be neat and organized. That's what I try to tell my elementary algebra students and my intermediate algebra students as well. It's all about being neat and organized. Now, if you need to use a calculator because you don't trust mental math, use a calculator. We have those, that's okay. You're better off using a calculator than being really frustrated when you make a mistake because of a simple sign error. So take your time. Notice I draw arrows. You can add in extra steps if you need to. But we're at this point. So let's move that 10x over, and we use subtraction here. And then we'll add 8 as well. So the 8's cancel. And then we have a 9 minus 10x. That leaves you with a minus x. A minus 5 plus 8. Well, minus 5 plus 8 leaves you with a 3. The 10x's cancel. We're going to finish this by dividing by a negative 1. And now we've got our second solution, which is x equaling a negative 3. So those are going to be your two solutions there. But where students get frustrated at is when they lose track of where they're at or make a simple sign up. So take your time. Try to be nice and neat and organized. Otherwise, it gets really confusing. And I see students do this all the time. They know how to solve them. It's just that you lose track of what you're doing, and then you get frustrated, and it's hard to proceed on. So always take your time. Don't ever feel rushed. Did we have any others out of 1 through 4 and 1-8 to look at? Are we okay with the others? So those are okay. All right. So what we're going to look at now is we're going to look at absolute values with inequalities. We did absolute values with equalities last time. Those are 1 through 4. And today we're going to be talking about the inequalities. These are not difficult as long as we remember where to shade. Again, greater than, less than, those get parentheses. Greater than or equal to, less than or equal to, well, those again are going to get square brackets. When we go to graph these, it's going to be graphed one of two ways. And how we determine where to shade is we look at our inequality. Now, when we look at this inequality here, okay, here's my absolute value, the inequalities here, and this inequality points to the right. And how I remember is when it points to the right, you want to shade to the right. And so this one would come out to look like this. Okay, this is what your answer will be. Okay, if it points to the right, you've got to shade to the right. So I just remember, points to the right, shades to the right, and also shades to the left. So if your absolute value points to the right, the way I remember it is you shade to the right. Okay? If it points to the left, then you shade in the middle. Basically, you shade to the left. Points to the right, shade to the right. Points to the left, shade to the left in the middle. So this one what does this one do? This one points to the left. So we shade to the left in the middle. So this one would look like that. It's just easy if you, the way I remember it is I just think shade to the, points to the right, shade to the right, shade to the right and left. Shade your edges. Okay, so if it points to the right, you shade your edges like this. Shade the edges. If it points to the left, think left, meaning here, so I'm going to shade in the middle. That's all you really need to remember. It's exactly the same as what we have done before with the equalities, only we have to shade them. So now we're going to have to solve this one out. Now this is going to be an inequality. So this is what we're looking at here. Now, first thing we need to do is we need to solve it just like it was an equal sign. So we're going to get our two numbers again, just like we did before. But they're going on a number line. And which way does this one point? Okay, look at this one. This one's going to point to the left. So we're going to be shading in the middle. Right? Points to the left, shade back to the left. So what do my two equations look like? Well, they look like 3x plus 4 equals 5, or 3x plus 4 equals a negative 5, right? We should have no trouble solving this. So let's just quickly work through this. 3x equals 1. So x equals 1/3 there. Move that 4 over. 3x equals negative 9. So x equals a negative 3. We are not done, though, because this is an inequality. So that means we must graph it. Make sure they're on the number line in the correct order. Now, what do we know about this? Which way does this one point? It points to the left. So that tells me I'm going to shade in the middle. Shade kind of to the left. So what would this look like? Well, we're going to have to use square brackets. And where's my answer going to lie? In between here, and here it is. And in interval notation, that is square bracket negative 3 to 1/3. Why does it look like this? It looks like this because this points to the left. So shade to the left in the middle. And that's just the way I remember. I think, okay, points to the left, you got shade in the left in the middle. Now, when we work these out, it's either going to be in the middle or the edges. That's it. So it's either like this or like the other one where it's on the edges. But don't try to make these more difficult than what they really truly are. A lot of times, students miss these. Points to the left, shade in the middle, shade to the left. Points to the right, shade on the outer edges. So let's do another one. So how would we handle this one? Well, for this one, just like when we work with the equalities, with these absolute values, that absolute value has to be by itself on the left. Nothing else but the absolute value belongs on the left-hand side. So that 5 does not go with the absolute value. So we need to add that 5 to the other side. That way we get the absolute value all by itself. And minus 2 plus 5, that makes it a 3. So that's what we've got. And that's what we're going to be checking it and thinking about how to shade it. We know we're going to be shading to the right, so that means we're going to do the outer edges. What do my two equations look like? Well, they look like minus 2x plus 9 equals 3, or minus 2x plus 9 equals a negative 3, right? We have a positive set of numbers and the negative set. We solve them out. Move the 9 over. So minus 2x equals a 3 minus 9. That's a minus 6. Divide by our negative 2. And that leaves you with one of them being x equals 3. Repeat the process with the other one. The 9 over. So minus 2x equals minus 12. Divide by your negative 2. And x equals now positive 6, right? Now, we are not done yet because we have to graph it. So let's look at our inequality. Look at this one. This one points to the right. So that means we shade to the right. We want the edges. Okay, we're going to shade to the right. That's the way I remember it. Shade to the right, but you also have to shade to the left, because it's going to go on the edges. So what's that going to look like? Put our numbers on the number line. We have to shade to the right, shade to the edges. I found that students get confused with these, so I say if it points to the right, you're going to shade to the right. But that also means shade to the left, so it's going in both directions. So here they are. We've got 3 and we've got 6. Points to the right, shade over here. We're going to use parentheses. And it looks like that. It has to either be on the edges or in the middle. So if it's pointing to the right, you shade to the right over here. If it points to the left, you shade in the middle. And I've tried different ways of teaching it, but I think this is actually the easiest way for students to remember. What does it look like in interval notation? Well, it's negative infinity to 3, U for union, 6 to infinity. And that's your answer in interval notation. Because this is negative infinity, and that's positive infinity. So let's do at least one more, probably 2, and then we'll look at some special cases where they're negatives. Okay, so we have to first find the 2 numbers. They're called critical points. That's a technical term. A lot of times they say find the 2 numbers because they go on the number line. So what are my 2 equations going to look like? Well, they're going to look like 3x plus 9 equals 9. So that's one of them. Or 3x plus 9 equals a negative 9. And now we just finish it. We move the 9 over. So 3x equals 0. So x equals now 0. The other one, we move the 9 over. So we have 3x now equals a negative 19. Divide by our 3. And we've got x equals a negative 6, don't we? We are not done yet, though, are we? Now we need to go back and we need to look. Which way does it point? It points to the left. So that means we shade to the left in the middle. Points to the left, that means we're going to shade to the left in the middle. So put them on the number line. And here is my negative 6. Make sure they're in the right order. And here's my 0. Okay. Points to the left. So I always think about this point here. Shades back this way. And where's it going to be at? It's going to be right here in the middle. It's either in the middle or on the edges. And so this one's in the middle because it shades to the left. So I just remember shade in the middle, shade to the left. And what does that look like? That looks like negative 6 to 0. And that's it. One more, and then we'll look at some special cases. And same process as we've done before. 2 equations, minus 2x plus 1 equals 5, or minus 2x plus 1 equals a negative 5, right? Work these out. So move that 1 over. So minus 2x equals 4. Divide by our negative 2. And so one of them is minus 2. Repeat the process. That gives you a minus 2x equals minus 6. We divide by our negative 2. And x now equals 3. Are we done yet? No, we are not. We need to finish this. And what do? I look at which way that it points. So, which way does it point? Looks like it points to the right. So that means we're going to shade the right, the outer edges. Put them on the number line in the correct order. Minus 2, positive 3. We know we have to shade, points to the right here. We also have to shade backwards. So that's negative infinity to positive infinity. And that now is negative infinity to negative 2 with the square bracket. We use a U for union. We need now a positive 3 to infinity. Is everyone okay with that so far? So we see how that's going to work. Now, I did kind of make it a little bit easier on your homework on these because I know students still tend to sometimes get mixed up. So that's why I made 5 through 10. I made them multiple choice to make sure you know which way it goes. It's either going to be on the edges or in the middle. So if it points to the right, you shade to the right on the edges. If it points to the left, you shade in the middle. Now let's talk about the special cases, when it's negative or when it's 0. Since it's negative here, when the right side is negative, it's either true or false. So just like we talked about earlier today, when we did the squares, right? Remember earlier today, we talked about the squares. And when we squared a number, we know that when we square a negative, it becomes positive, right? And 0 stays 0. So they're always positive or 0. Well, what happens with an absolute value? When you take an absolute value of a negative number, it becomes either what? Well, if it's a negative, it becomes positive, and the absolute value of 0 is still 0. So, we look at this as positive or 0. And then we look at it and we see if this is true or false. Our positive numbers are 0. Are those bigger than a negative 12? Are positive numbers bigger than negative 12? Is that true or is that false? Look at the way it's opening. Are positive numbers bigger than negative 12? True or false? True, right? Positive numbers are bigger. Remember, it always points towards a smaller number. So it's pointing towards negative. Negative is smaller than that positive. So that is true. So that would mean you would have all real numbers. What if it's the opposite? Okay, what about this one? What do we know about absolute values again? Positive or 0. Are positive numbers, are they smaller than a negative 15? Are positive numbers ever smaller than negative 15? No. So what would this one then be? This would be false, and this one has what? No solution. Let's do a couple more just to make sure so we understand what's happening. Why do we look at it like that? Because that is negative. And whenever it is negative, it's either on the right, it's either true or it's false, irregardless of the absolute value. Let's do another one. This one. Now, what do we always do first? Before we do anything else, we need to make sure that that absolute value is by itself on the left. It has to be isolated and all by itself. It has to be alone. So that 19 does not belong there. So move that 19 over and then see what you're left with. 2 minus that 19, well, that makes it a minus 17, right? And again, what do we know? This is negative, and since it is negative, that means it is either going to be true or false. So what about this one? Positive numbers are 0. Are those going to be smaller than a negative 15? Or sorry, negative 17. Is that true or is that false again? False. And if it's false, that's like a contradiction. So it has what? No solution. What about 0? Let's do one with 0. Well, what do we know about this one? Again, let's think about absolute values. What comes out of an absolute value? Positive numbers or 0. And our positive numbers are 0. Are those going to be bigger than 0? Bigger than or equal to 0? Yeah, they can be either bigger than or 0 could equal 0. So that would make this one then true, and this would have an